One experiment that he was doing is detecting the number of particles that were being emitted by this radium bromide as a rate, so he would measure the number of particles per minute that the radium bromide was emitting. And what he used was a detector here, so he could detect how many particles were hitting this detector. He'd actually developed this detector with a postdoc by the name of Hans Geiger. Does that name ring a bell? A Geiger counter. So this, in fact, is my very schematic representation of a Geiger counter. For those of you who don't know what that is, it's simply an instrument that counts radioactive particles in the air. And now that you're at MIT, you'll all have a chance to see one firsthand if you're ever in any of the labs, especially in the chemistry or bio labs. As carefully as people work with radioactivity here and using often much, much safer radioactive materials than radium bromide and using them in special hoods and having special procedures, they still do a lot of checking with these Geiger counters to make sure everything's safe. You'll actually see a man walking around with one, sometimes in the halls, just kind of like this. You hear that click, click, click. That's a good sound. It means low levels of radiation. He'll walk by your hood, so click by your hood. I always get a little nervous when he walked by my hood. I don't know why. I never worked with radioactive material. But I was convinced I'd hear the click, 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 which is what tells you you're in trouble. So I've never heard the click, 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 click. And we might bring a Geiger counter in here sometime later in the semester so we can check all of you out. And hopefully we won't hear any when we do that either. So one thing that he discovered with this detector initially, and he was the first to discover this, is that radioactive material, including radium bromide, have a characteristic rate that they emit radioactive decay. So basically, they're decaying at a constant rate, which means, of course, that you can figure out how old things are by seeing how much they've decayed. So he was really the first person to discover you could do this, which was used to make the first somewhat close approximation of the age of the Earth. So that's a pretty exciting set of experiments he did. But one thing that he wanted to do specific to understanding the atom and using these alpha particles, these heavy charged particles, was to test if this plum pudding model actually fit what he could observe. So what he did was he first recorded the count rate of radium bromide before it's going through any kind of plum pudding atom. And he found that it had a count rate of 132,000 alpha particles per minute were being detected by this Geiger counter.